Welcome to AP Physics 1. These videos are meant to kind of help you out if you get stuck on a couple of these problems. Right now we're going to be looking at part 1. Part 1 is pretty important. You find that throughout the class, the vast majority of algebraic problems actually involve hardly any numbers. And you're going to be asked questions about the relationships between the variables and have to solve for a quantity without having any numbers, which means you're going to be doing a lot of variable algebra. So let me just go ahead and dive right in. Let's go through a couple of these. Let's look at number 1. Number 1, we have the v squared equals v naught squared. That little sub-zero down there indicates initial, so I call it v naught. So v squared equals v naught squared plus 2ax. It's asking us to solve for a. So what we're going to have to do is use order of operations and isolate our unknown variable a. All right. So the first thing you're going to want to do is subtract this v naught from both sides. All right. That gets everything in its own little world here, 2ax. So we're left with v squared minus v naught squared equals 2ax. Now in order to get a by itself, we just simply divide by 2x, and then we're all good. And so you can see the 2 and the x cancel out, and we're left with a equals v squared minus v naught squared divided by 2x. And that's it. It's really not too bad. Where things get a little bit complicated is looking down here like number 5, for example. Now, first off, number 5 is asking you to solve for lower g, little g, in terms of variables big M, little m, and a. Now, right off the bat, we can see that big M is different than little m. All right, now that's a common theme you might see. For example, big K is different than little k. Anyway, going to solve for g in terms, when I say in terms of variables, that means I want little g equals, and then whatever is to the right of that equal sign must be made up of big M, little m, and a. So if you went ahead and solved it just like we did in part 1, in number 1 here, and you would have gotten something like g equals big M, a minus f sub t divided by like negative big M, right? That's just doing it off the top of my head here really quick. But that would not be correct. That would not be correct. It would be accurate, but it's not what the question is asking. The question is asking for you to solve in terms of variables m, and a, and we have this big ft in here. So this is not right. So what we have to do, and I recommend doing this right off the bat, is we have this secondary equation where we have ft is equal to mg. So we're going to go ahead and we're going to take this little m, little g, and we're going to plug it in right here into our main equation. So that gets us, if we rewrite this, ma equals ft minus mg, and we go ahead and we plug in little m, little g in for ft, so we get big M, a equals little m, little g minus big M and g. Now, a little trick here. For example, my handwriting is terrible, and my big M's might sometimes look like little m's. If that's a problem for you, go ahead and substitute in just like an M1, M2, kind of like what we see in number 4. That way you don't have to be differentiating between uppercase and lowercase. It can be a little confusing. Now go ahead and just follow order operations, isolate the little g, you want to factor out g, and then divide by m minus m, and that should get you your final answer. We'll be discussing this in class, so if you have any questions on any of these, you're still stuck, go ahead and send me an email or a Remind 101 chat. I'll be happy to answer any questions you have. All right. Good luck.